Hi, my name is Richard Ney. I'm a principal with Lookout, a company that deals with mobile security. My talk, as part of our ingestion query team, we are moving from Dynamo and other AWS resources into Scylla database for our name value store in order to save money and scale in a more predictive manner. Hope you enjoy the talk.
My name is Richard Ney. I'm a principal with Lookout, and I've been doing software development for around 30 years now, dealing with ingestion pipelines and storing and retrieval. Currently, the main team I work on at Lookout is the ingestion and query team. So what does Lookout do? Well, our primary goal, as was mentioned in the intro, is we provide security scanning for our mobile devices. How many of us have our lives living on these machines? Yeah, so back in 2004, the original founders of Lookout found a vulnerability in the Bluetooth protocol on the Nokia phones. Now that used to also be a hot item like the iPhone, but back in the past. And they brought it up with Nokia. And the guys at Nokia, they said, oh, thank you, but this is really not exploitable. You got to be practically standing next to the guy to pull it. So the Boffins, going for old archaic terms here, at Lookout created a interesting device that kind of looked like a giant sniper rifle that was a directional antenna. And inviting the press, they basically climbed up on a roof of a building about a mile away from the Academy Awards and proceeded to demonstrate sniping phone numbers and pictures off of the celebrities' phones as they were walking down the red carpet. So, as mentioned, we're right now trying to scale up, and I'm sure as everyone has heard from management, we need to take in more customers, but you can't spend more money. So, if you look at how we're doing things right now, our primary product is our enterprise. We also do consumer devices, which is why if you look at several different vendors out there, you might find Lookout on your phone. But our enterprise customers, they want to apply certain corporate policies, report on risky behaviors, and control what's part of their enterprise. Now, in order to apply these, we have a whole bunch of information that we're pulling down from everybody's phones in a constant basis to figure out, are they within compliance? So one of our services, and the one that currently is heavily Dynamo, is what we call the Common Device Service. A nice original name here. And it functions as our on-site proxy for all devices. And as you can see, we pull down a good amount of information, what operating system's on there, what the hardware looks like, all the way down to how is your permissions and settings set up? Are you doing something that is quote-unquote risky? And this is kind of what our flow looks like today. A beautiful AWS diagram here where all the phones keep on a regular basis phone home, push a bunch of information into our ingestion pipeline. And it comes through, Kafka goes in through a set of ingestion jobs, and we push out into Dynamo and Elasticsearch. And then to tell everybody, all of our other microservices what's going on, we basically then have a message forwarder hooked into Dynamo streams that pushes everything out. So it's a pretty good architecture, and we have a lot of good benefits on it. For those of you who have used managed AWS services, I'm sure you've experienced many of these. Really easy to set up, little to maintain. If you want to scale it, you just open up the AWS UI, do a few clicks, and you can take in more information. And it's cost-effective when you start, so you kind of feel comfortable. And if something unexpected happens, you can make changes. But we do have some long-term issues as we go up. So, as you saw in our ingestion pipeline, we're using Spark. But Spark is the EMR clusters within AWS are single regions. So if I'm going for high availability and I'm deployed in US West 2 AZA, and that goes down, all my ingestion pipelines go down. Then as the costs grow, So does our DynamoDB costs. And there's certain limitations. While they have like Scylla good PK retrieval, if you're using their sort key and you want to say, give me all the records with the same PK and I don't care about the sort key, you have to switch over to their querying API, which has a performance hit on top of it. And as I was mentioning, it gets really expensive as you scale. Now, these are all on-demand numbers, but you figure as we start getting up to 100 million devices, we're putting out about $1 million a month in costs for Dynamo alone, not even concerning all of our other pieces. So this is a saying that some people might have seen out there with AWS, which is when you start out, it's really cheap to try new things out and fail, but as soon as you become wildly successful, they have you hooked on their APIs and you start paying more. So off we go. So what is needed for us to scale up to 100 million devices? As mentioned, we need something that's a highly scalable and fault-tolerant system because in the common device service, that database represents pretty much every device that we're providing security on top of. And we need to be able to ingest more and more telemetry as it comes in. So we need to be able to scale to support 100 million devices and at the same time be cost effective to us for the ingestion, in the storaging, and the querying at that scale. We want low latency because if you find out that you've got a massive piece of malware on your phone 10 minutes after you've installed that beautiful app from one of the stores, you've already been compromised, and the person who put that malware up there is basically looking at all the pictures in your phone. And we need to basically be able to have a failure handling. And this is a big one here. Since you're coming out of managed services, you need something that can handle ease of deployment and doesn't require a whole new team to be started up in your company to manage it. So why did we consider Scylla? A lot of us are very familiar with Cassandra, and I basically learned about Scylla at the AWS reInvent conference several years ago. So when we started looking into them, we basically were quite pleased since it checked off a lot of boxes. It was very, at the time we looked at the feature parity was almost exact between Cassandra and Scylla. And being an old timer, I tend to like my C++, so I was really happy that it was all written in C++ instead of Java because of the performance improvements. The shared nothing approach and the C-stars framework. The mechanical sympathy alignment between the sharding and the cores on the boxes was something that we really were excited about from the performance point of view. And then the ability to scale out horizontally, but keep the number of boxes down versus the Cassandra, and being able to tune job prioritization stuff. Since anyone out here has used Cassandra, you're spending as much time tuning it as you are using it. So this is the goal that architecture that we wanted to come with. We wanted to basically bring in Kafka Connect in place of our Spark, so we could basically set up a bunch of Kafka Connect servers and go into Scylla, and then once the database of record has it, push it into Elasticsearch. Now we do have this, laser pointing. We have this missing box. And as those of you who've been here for a day and a half, you've been hearing about this change data capture piece. If you remember the slide at the beginning, we were using Dynamo streams for all of our downstream notification. So change data capture here is a critical piece for us that's coming in as a major feature. So we weren't able to test this architecture, so we tested this, which is somewhat similar. Instead of our several million devices out there in the real world, we created a bunch of load simulators to simulate all of our devices. And we basically pushed all those into our Kafka topics, and we did Kafka Connect straight into Scylla. Now, there's some limitations over Dynamo. It's important to pick the right type of compaction. Something that we did experienced in the past with dealing with Cassandra compactions was the Achilles heel. So we were basically looking at the various types that we were looking at, and incremental compaction is something that was really exciting for us. Now, some of it comes down, these may be opinions on the limitations. Based on us, most of our data stuff is not that big, except when we start dealing with file systems and stuff. But if your storage requirements are very large as opposed to transactions, there might be wasted compute tied to it because you need the excess capacity. But that assumes that you're using low-cost EBS volumes, which we all know we don't want to use. I don't know how many of you guys out there have heard of FedRAMP. One reason we couldn't look at Scylla Cloud is if you want to sell anything to the federal government, you got to go through a bunch of certifications. So we decided to do a self-managed cluster because Scylla Cloud at the time, at this point, actually does not have FedRAMP support. There's no auto-scaling because we have a static number of nodes, and you got to design your schema normally to match the queries, so that was another limitation compared to us just moving into, say, a relational database. So I'm not sure how many people here know about Kafka Connect. This is just a quick slide that kind of goes over what it is. It's a worker model where you deploy your connectors into it, and the Kafka infrastructure manages the number of workers to what you tell to. So if you say, I want 10 workers and I have 16 partitions, it'll divide it weird. But if you have 20 partitions, you'll get 2 per worker. So it's kind of just a quick overview. So the final environment that we did for our proof of concept, we set up a full Kafka system with schema registries, Kafka Connect workers, and we split that across all 3 of our AZs for HA. ScyllaDB, we started originally with a 3-node cluster, and across 3 AZs, at the final endpoint, we came down to the point where we changed our replication to R2 and went across 2 AZs. And we spun up a large number of load tools across 14 instances of some pretty powerful C5 4XLs to generate a bunch of Avro messages for us. Now, as we were going through it, we got to a plateau, and we were trying to figure out where it is, because as we kept on increasing load and we were trying to increase all the task workers and the partitions in Kafka, we weren't seeing any increased throughput. So I kind of just bring up this little piece here where the default Kafka sharding function, based on how we were generating our keys, actually wasn't a good fit, and we found out that half of our partitions were idle. So we ended up creating a more updated version of the sharding function using a consistent hash based off of a murmur3 input. So this is kind of the final load that we ended up with. We emulated 38 million devices, generating a total of around 110,000 messages a second. And on the average, each of these simulated devices was sending us about 253 messages a day. Because we were worried more about ingestion, we didn't simulate the query loads, since most of our stuff is pushed out for streaming detection. We weren't as worried about that. And we ran the load test for 96 hours, just to make sure that the database had to go through some maintenance tasks. We did do a repair in the middle of it. And so as the results that we came up with, on the average, our latency was in the milliseconds, unless we overtax the system. And by overtax the system, I mean taking your core loads up to 95% and then running a repair across your cluster. We did that and did manage to push the cluster over the edge. which point then we did find out that our core reservations were not set properly, which is why we were able to have a maintenance task crater the cluster. So once we fixed that, we were able to do a repair. We still did end up with some timeouts, but the cluster survived through the repair with minimal increase in our latency. And as I said, we kept this thing running at 75, 90% for those 96 hours to try to see how much we could milk out of it. And we were actually very pleased. So what were the takeaways? Kafka Connect, we found provided a quick and easy way to add in new ingestion pipelines. And you guys were in the Kafka session yesterday where mine was referenced. He showed you some of the JSON that we created for our flow. We were, within about an hour, were able to replicate all of our flows in Kafka Connect by just making minor tweaks to our JSON and resubmitting them. For this test, we did use the Data Mountaineer's Kafka Connect connector because we felt it was easier to configure. And as I mentioned also, repairs, fairly expensive operation. But with the proper reservations in place, one should not fear the repair. And we would also found out, even though we liked Kafka Connect, one of the drawbacks we found with the Kafka Connect is you can't attach a debugger easily to it. So if you were ingesting stuff from Kafka and doing different things with it, it might be better to just create a new microservice and use a consumer group application. And the cost benefits were significant. And I put in here on-demand versus provision. If you remember my slide at the beginning where based on our numbers of 38 million tested, if we took that to 100 million, we would be dropping 800,000 a month. You can bring that down through paying AWS upfront and reserving your write units. And that brought it down to around 146,000 per month. But then you basically bring in Scylla, and based on licensing and stuff, we were basically talking divide by 100. We were only around 38,000 to handle our 100 million, and some of the maintenance costs required. So we do realize that it's not a problem-free database like an AWS managed solution. Here's a pretty graph to kind of illustrate the scale. And so like I said, we were quite pleased, and now that with CDCs available, we'll be starting to implement the architecture as we originally intended.